Okay, so my topic was compound inequalities, and I know that some of the groups already went over basically like what inequalities are, working them, on either side of the greater than, less than, or greater than or equal to or less than or equal to sign. But with compound inequalities, it's more of like a combination of two equations using some sort of sign to indicate which one is greater than or equal to or less than or equal to or whatever you need. So with our first example problem for our lesson, we just have like a real life example. We have a highway has a minimum speed of 35 miles per hour and a maximum speed of 65 miles per hour. I accidentally put a typo on my page, so it says 6 miles per hour, but it's supposed to be 65. So the first thing that jumps out to me at this problem is that 65 is a bigger number than 35. So we already know that 65 is greater than 35, so we can write that as an inequality. But because we kind of want to think in the way of compound inequalities, the way I'd want to write it out is 35 is less than or greater to x, and x is less than or greater to 65. And that's just one way you can show your answer. You could also show it in a visual way. So to show this visually, you'd want to put it on a number line. I wouldn't show every number from like 35 to 65, but you just want to have 35 to 65, a dot above each number, and then a line connecting it. And the reason for the solid dot on the number line is because it's less than or equal to. If it was just like 35 less than x is less than 65, it would be open dots. Okay, so the next problem is to solve for x. 1 minus 2x is less than or greater than 3, or 3 minus x is greater than or equal to 8. And so this problem is a little bit different. The last one was an and inequality, and the difference is this time it's an or inequality. So the way I'm going to approach this problem and kind of want to expect students to do it is to break it up into two parts. So if you have the left side of the inequality, which is 1 minus 2x is less than or greater to 3, and to solve that you just want to do some algebra. So subtract 1 from each side, and then you're left with negative 2x is less than or greater to 2. So then you just divide the whole thing by negative 2, or just divide each side by negative 2. And when you divide a negative number for like an inequality, the sign switches. So if it was less than or greater to, or if it was less than or equal to before, it's now going to be greater than or equal to. So even though we divided by negative 2, you might think that the answer would be x is less than or greater to 2. It's actually x is greater than or equal to 2. Then next you want to go to the right side of the or, which would be 3 minus x is greater than or equal to 8. So to start off with this problem, you subtract 3 from each side of the greater than or equal to sign, and you're left with negative x is greater than or equal to 5. Since it's just negative x, you divide both sides by negative 1, and just like last time, the sign flips, and you're left with x is less than or greater to 5. Then you just put it all together, so x would be greater than or equal to 2, and then move that or down, and x is less than or equal to negative 5. And again, if you wanted to answer this visually, you would put it on a number line, and it would just be a solid dot and a solid dot above 2 and 5, and then a line connecting between them. Okay, so for problem C, we have Sean, and he wants to take the bus to get to the Mariners games this season. And he's got two options to do it. So his first option is he can purchase the Smart Pass card for $10 and pay an additional $2.15 for every trip to T-Mobile Park. Or the second option he cannot get the Smart Pass card and just pay $3.15 every time he goes to the ballpark. So the question for this is, after how many trips is the cost of option 1 less than the cost of option 2? Because obviously if you're just going one time to one game, option 2 is the cheaper option. Why would you pay for the Smart Pass card if you're only going to go to one game? So what is the number of trips that option 1 becomes the more efficient option? Okay, so the first step I want to take on this problem is just put down a 10, and I'm going to throw this 10 down in the middle because it represents the Smart Pass. Now on the left side of the 10, I'm going to put a less than sign to indicate that 3.15t is less than 10. And then on the right side of the 10, I'm going to add 2.15t, and that represents the $2.15 that you add every time to the Smart Pass trip. Next, we're just going to do normal inequality operations to isolate the variable. So I'm going to subtract negative 2.15t from each side of the less than sign. And what we're going to have left is 1.00t is less than 10, or t is less than 10. What the t is less than 10 represents is that after 10 times, at the 11th trip, it is more cost effective to use option 1 as opposed to option 2. And so we can test it out. So if you see on the right side, I tested it for trips 9 and 8, and both times option 1 was the more expensive option. But if you look on the left side, the 10th trip is the first time that they cost the same amount, and then after trip 11, from that point on, option 1 is the cheaper option. So for the question, how many trips is the cost of option 1 less than the cost of option 2? The answer is after 11 trips, option 1 is more effective or more efficient than option 2. Okay, so I had a teacher in high school who would format her lessons like this. She would give everyone a handout, and then in front of the class, she would work on the handout in front of us, working aloud, stopping for questions, pausing for, letting students catch up. And it was just kind of a format I really liked, because rather than just kind of telling people information about math, it's like they're watching the process of somebody doing it. And I just think that it's a lot better. I shouldn't say better, but it's just like the way I like to run my lessons. I like to make sure that it's like me working and people are just kind of seeing my process. So if they have any questions, they can just ask me, why did you do that specific step, rather than just giving them the solution outright. And I just think it can be a little bit harder to follow when you're not doing it step by step. And so like after her lessons, she would wrap it up by giving us like a homework assignment. So I'm not going to go over the homework assignment, like all the solutions that I came up with, but pretty much what you would do in my class is like at the end of my lesson, like the last 10-15 minutes of class, if there's extra time, I would want to give my students time to start their homework in class. I don't know, I just think that's like a mental thing. Like if you give students time to work with their homework in class, they feel like they don't have as much to do at home. It just makes them more eager to do it. So I'm going to go over my assessment now. So this is pretty much the format of like the homework. I only put 3 problems, but if it was like a real life assignment, it would probably be closer to like 6 to 8 problems. So starting off, it's just asking you to solve for x, and it's got a and inequality, because I just think like the biggest thing for me with compound inequalities that I noticed was like you just want to have an example of an and inequality, and then the second problem, which is an or inequality, because how they look on a number line is much different sometimes, and how it illustrates is a lot different. So I tried to get a mix of like multiple representations of problems. As you can see, for like problem 1, they have less than or equal to, but then for problem 2, it's less than and greater than, no equal to's. And then for problem 3, it's a less than and then a less than or equal to sign. And I only asked for the second two to be on a number line, and the first one I didn't ask to be on a number line because I feel like the first problem of a homework assignment should be really easy and should be the shortest because it just builds confidence in the students and it just makes them feel like they're working through it faster. So the last problem would be -5 is less than or greater to 2x plus 3 is less than or 7. And the whole point is like you're finally working the whole compound. Like it's a compound inequality, but it doesn't say it. Like you could break it up into 2 parts and work on it, or you could just do algebra on the whole thing to solve it. So students will probably take different paths, and I just think like that's kind of the whole, like lessons should flow. Like I'm kind of hoping that, you know, the handout helps students solve the homework, and like that's kind of the goal. It's like as long as the lesson makes sense and they can use what they applied in the lesson to help them do their homework, that's kind of like the goal of how you would know that like this kind of format is successful. If you're doing like handouts in class and then your students are struggling with the homework, you probably need to readjust the information you're putting on your handout because obviously they're not helping the students.